Welcome to my video on estimating the mean of a population when sigma is unknown. This is my second one. First one we looked at estimating the mean when sigma was given. This one and we used the z-value to create the confidence interval. In this one you'll be asked to estimate the mean of a population, and the population standard deviation, which is sigma, is not given to you. The formula is given here. And it will be provided. You're supposed to have it during the test, so no worries about memorizing any formulas after this chapter. Including this one. Now it says, let's look at an example. I've taken the third example from your PowerPoint. In a crash test of 15 Honda Odyssey minivans, so there are 15 cars, so N is 15. Let's see, it says the distribution is roughly bell-shaped, whatever. Well, if it wasn't, you couldn't have done any of this to begin with a mean of 1,786, and I told you on the first video, every time they give you the mean in the problem, it's definitely the sample mean, because it cannot be the population mean. Because if you think this is mu, then why are you doing this? The whole idea of doing this is you don't have mu and you want to estimate it. So if you think that's mu, then why are you trying to estimate it? So that has to be x bar. So anytime they give you the mean, it's definitely x bar in this chapter. So the mean here, the sample mean, is 1,786. So x bar is 1,786. Your sample standard deviation, it says sample, so that's how I know it's not sigma. Your sample standard deviation is 937. 937. Now what's the difference? Well, if you have sigma, previous video lecture on Excel, you have to use a z-value. If you have S, meaning sigma is not given, it's the same formula. The only difference is, instead of using the z-value, you will use a new distribution called the t-distribution, so you use a t-value. Pretty much you look like, I have the picture here, it pretty much looks like the z-distribution, probably a little thinner. It's called the t-distribution, and getting into it is another story. So for now, all you need to know is how to calculate the t-values, known as critical values. Well, if you type norm, if you're doing a normal distribution, in order to find the t-value, you have to type t. So let's see if that will come up and see what we need to type. Now, when I type t-distribution, you see there? So, and we're doing an inverse always in this chapter. So t inverse, you see there's a t inverse and then there's a t inverse 2t. So either one, I'd recommend you go with t inverse 2 tail. Okay, so t dot inverse dot 2t, that's the one you use. And it says probability. Well, it says 2 tail. Basically what it wants you to figure out is what's the probability in the tail area. This is the belly area, which is 99% is given. Now how do you find how much is in the dark blue area, which are the tails? So it's obviously 100% minus 99. So 100 minus 99 is 1. I'm going to use decimals. 1 minus 0.99 is 0.01. So you type 0.01 there. So you're basically typing the area in the two blue areas here. So, and the way you do it is always 1 minus the confidence level. And confidence level is always given to you. And if it's not, you always assume it to be 95 anyways. But if it's given, then you just subtract that from 1 and it tells you what to type here, comma. And you'll come across something new called degrees of freedom. Degrees of freedom is just your sample size minus 1, always. So the way you find what the degrees of freedom is for your computations, you'll just take the sample size, which is 15, and you'll lower it by 1 unit, so you get 14. So the degrees of freedom is always the sample size minus 1, and it gives you the value, 2.976843. Now again, depending on how many decimal places I ask you for on the test, you'll use that many decimal places to do your calculations. And of course, it gives you just one value. I mean, that belongs to that score right there, that number there. But then the other side is the same thing, but with the opposite sign. So that will be negative 2.97684. That will be positive 2.97684. But for your calculations, you just use the absolute value. You just don't worry about the signs. Just use the number itself. So let's say I ask you for 3 decimal places here. You'll have to type 2.97, and 6 updates itself to 7. So 2.977 will be the one you would use here. So let's calculate the left-hand side, right-hand side, or lower confidence limit and the upper confidence limit, just the way we did it in the previous video. So it's equal to, the left hand side starts again with x bar, so you type x bar minus the t-value, which is that, times the standard deviation, s, which is 937, divide by square root of n, so sqrt of n is 15. So that's how you will type the left hand side of the lower confidence limit. Let's type the upper confidence limit. It will be x bar, but this time plus, not a minus. The good old t-value, which is that one, times the standard deviation, which is that one, sample standard deviation, divide by square root of n, which is 15. And that's my right hand side of the upper confidence limit. So therefore, I may not know what the exact repair cost is for a Honda Odyssey minivan, but I am 99% confident that it's somewhere between $1,000 to $2,500. That's how much it costs approximately to repair a Honda Odyssey minivan. And again, the way you would write it is, I'm gonna forget about the symbols. You just write mu is less than or greater than. So mu, I'm just trying to do it in Excel. You'll write this with the actual mu with your pen. So the left hand side, let's say I want, see, these are big enough numbers so I don't need to worry about decimals. What difference does it make it if it costs $1,065.76, or you just say $1,065? So if I give you a problem like this, I'll probably ask you to round it to the nearest whole number. So your lower confidence limit will be 1066. And your upper confidence number will be 2506. So that'll be the range of your repair cost if you're estimating the actual population mean. And that'll be the end of the problem. Thank you.